Well, hello everyone, and welcome to the latest FlightGlobal webinar. Today we're going to focus on a technology or a series of technologies that has the potential to transform the way aircraft are designed and manufactured. Digital engineering has been described by the US Air Force as the new stealth, a breakthrough way of working that, as with other Fourth Industrial Revolution or Industry 4.0 innovations, could hugely reduce the time and the cost involved in bringing new platforms and capabilities to market. Now, our webinar today is sponsored by Siemens, whose accelerator portfolio of software and services plays right into this opportunity. And joining us today to explain how it all works is Dale Tutt, Vice President of Aerospace and Defense Industry for Siemens Digital Industries Software. And with Dale on the panel are leaders of 3 aerospace companies, although one of them for the moment is having technical difficulties, so is still to join us, but we're fingers crossed that we'll get him on board. And they're going to explain how digital engineering tools that allow design teams to work more collaboratively and productively are helping turn their businesses into more agile digital enterprises. Now we're waiting, as I said, for Bissell Smith, the Chief Information Officer and the EVP of Enterprise Systems with supersonic developer Arian Air Supersonic. Hopefully he can join us as the webinar continues. We're also joined by Professor Andy Schofield, Manufacturing Technology Director with BAE Systems Air Division, and Paul Niewald, Senior Director and Chief Engineer on the T-7A Advanced Pilot Training Program with Boeing's Strike, Surveillance and Mobility Division. Now, just before we begin our discussion, I'll briefly outline the format. We're live for the next 55 minutes or so, which means that you have the opportunity to ask questions of our experts via the Q&A icon at the bottom of your screens. And helping me process and help process your questions and help with any technical queries behind the scenes are my colleagues, Chloe and John. So Dale, perhaps I could start with you. Digital design technology has been around for a while now. We haven't been designing aircraft on drawing boards with set squares and pencils for many decades. So what's the latest leap in capabilities that you feel the industry needs to embrace?
Yeah, that's a great question, and thanks, Murdo. And I'm very pleased to be here today with you and Andy and Paul and the rest of the team. And funny enough, I'm just old enough, or maybe just young enough, to remember that transition of moving from drafting boards, these rooms full of drafting boards where you were designing rockets and airplanes, to moving into computer-aided design. And so, I think that when you think about where things are at and where they've come, for years we've been talking about paperless systems, and I sometimes think for a while we created more paper than ever in going to paperless systems. But you really, as we started down this path, and we started with digitizing, so we were just changing the medium. So instead of using a drafting board, you were doing computer-aided design and drawings on the computer. And as you did your analysis, you were moving from maybe hand methods to numerical methods and computer simulations. And I think the thing that has really transformed the way we're designing and building airplanes now is moving from these individually digitized elements to really this comprehensive digital twin, which is fully connected by digital threads. And so I always tell people, when the difference between the twin and the thread to me is, the twin is what are you doing? What are you designing? What are you analyzing? And then the thread is the context and the how. And being able to have this seamless transition between these different elements has really changed it. So, and I'll just give a quick example, and then I'll turn it back over. But, I think about, let's say 5 years ago when I was, leading another program, we would start from, we would have a computer drawing, or we'd have a 3D model of a part. We would then hand it over to the stress guys, who would convert it into their meshing tool, and then there would be another data translation while they were doing their analysis. And then they'd mark up a drawing and they'd send it back to the designer and they'd start the whole process over again. And that's an extremely inefficient process. And I think now with what you're seeing with the tools, when you start talking about digitalization or digital enterprise, digital transformation, is really that ability to move that data more seamlessly back and forth and actually be collaborative. And you've automated a lot of those processes and you're freeing up the designers to actually go solve problems, not manage data. So I think that's the big change that's happened, especially in the last 5 or 10 years with digital transformation, digital enterprises.
Okay, thanks, Dale. Paul, let's move on to you. You led the design and development effort that took the T-7A from concept to first flight in just 36 months. What part did digital engineering play in this effort?
Well, it played several roles. It was a significant enabler, obviously. We used a lot of CFD, computational fluid dynamics, at the very beginning to define aero and loads to help inform what that physical design would be. And like Dale said, with a product definition software, we could work collaboratively with a single source of data for all the teams to work in. Whether they be the designer or the analysis, everyone was collaborative and working in that same environment. And we kept a cadence so that one team didn't get out in front of the other. Typically on aircraft developments, you can have the structures team designing structure, releasing parts and fabbing, as the subsystems teams are helping define the subsystems, the routings, the penetrations, and you always would have this loop back. Keeping on that same cadence and keeping at the same maturity level so that the structures and subsystems teams were in line with each other, so we weren't releasing parts to fabrication until all the definition was complete. Was a different mindset for our team because we're used to the traditional methods, so we had to hold off a lot on releasing parts, which seemed counterintuitive, but enabled us for faster manufacturing in the near future. Then, but the digital engineering allowed us to, as Dale was saying, the digital thread allowed us to connect a lot of things together that previously we hadn't, so that we could all have that information at the same time, and we were all working with the most current data set that was available.
Right, fascinating stuff. Thanks, Paul. Andy, if I could move to you, how is the fourth industrial revolution playing out at BAE Systems, and what role is digital engineering playing in this?
Yeah, so it's vital. I think we would describe over many years of being able to design, engineer and manufacture fast jets within the air sector, that we would probably have pretty sophisticated methods to be able to do that. And even if we go back to the 90s, when we designed and engineered the Typhoon aircraft, that was the first aircraft designed in 3D, and the digital model drove a number of our processes through from tool design through to inspection through to the manufacturing processes. So we had a sort of 3D digital thread there in place, and so we've got a fair amount of experience. But we know that when we look at the next generation aircraft, replacements of Typhoon 2035, and the challenges that brings, particularly around the demands of that platform, then we know that the current methods aren't good enough, and we have to shift the paradigm. So using Industry 4 methods and techniques, and setting up a series of technology themes that we feel certainly within the manufacturing area, are critical to address those challenges. Digital manufacturing is a key one. And that opens up a whole series of opportunities and particular capabilities within digital manufacturing, particularly the connectivity, the word that was used a couple of times. The connectivity is so vital. So around our supply chain, the connectivity with supply chain around the data, the use of digital twin, as we've talked about, the control systems, the condition-based monitoring and maintenance, predictive maintenance of our machines. So the digital elements are all the way through, and that is a great opportunity. And I think if you look at any sector, whether it be transport, automotive, commercial aircraft, defence, then we all have the same challenges of improving our productivity, reducing the amount of non-value added activity and waste in the supply chain and operational areas. And digital is key to it. It's one of our major technology things.
Excellent. Just a reminder to our audience, thanks for joining us. Please, if you've got any questions, use the Q&A icon at the bottom and to get your questions in, and we'll get through as many of them as possible over the course of the hour. Now, something that occurs to me, I think you've all talked about the collaboration with supply chains and cooperation. Are there security issues around this when you're cooperating with other organizations? I mean, does this make it? Are there security challenges? Does this make things more secure? Dale, do you want to just come in on that?
Yeah, it's kind of interesting. I think as you actually build a more collaborative environment where people can participate in it, you're actually leaving that data more in that environment. You may actually be able to have more security. I always joke that as we first started going digital, that it made it easier to email everything out to the wrong people, and so we could you sometimes didn't have the tools in place now. But I think now when you start to collaborate and you're in this digital environment, you're in the being able to collaborate, you keep that information in there. It's actually easier because you're able to have the partitions, the protections. So, be able to, provide data rights management, be able to, provide the export controls so that you can make sure, especially when you're talking with suppliers or working with even employees that are in places around the world. You have so many global companies, and you have to be able to protect your data. To prevent export or compliance issues. And so, because you have everything is in the environment, it's accessible by everybody, but it's also partitionable to the people that don't need to see it. So I think you actually are able to maintain better collaborative control, both internally within your company, being able to separate between different projects, but then when you start working with suppliers, to be able to extend those same kind of controls out into the supply base and into the manufacturing base, and then even looking forward into the product support arena to be able to provide those collaborative a collaborative environment, but a controlled environment.
Yeah, I mean, for the other two panelists, I mean, you're working not just in a commercially sensitive environment, but a security sensitive environment as you're working on defense products. There's obviously a huge opportunity with this technology. Are there challenges as well around the security side of things, or is that something that you're able to control fairly easily?
As I will say, I'll just tag on with what Dale was saying. The tools allow us to containerize or provide the access that we need to provide to the supply chain if they need to come in, reach in, grab the definition for the parts. We're able to make sure what access they have, and so it does make it easier instead of extracting and then sending out. So that has simplified some of that supply chain, so that there aren't transactions going forward. With the digital environment now, it's more about access more than deliveries. And so I think as we continue to evolve, we'll see different types of access partitioning so that we can protect people's IP. If there is classification or export levels as well, that can all be well played out with the tools we have today.
Yeah, and I think just to add to that, what comes with a great advantage of the digital world and the transfer of digital data comes the challenge of that cybersecurity issue of 3D printing, for example, of bureaus who can print components where data is provided to them. The control of that data and the security classification of it is a challenge, and that's one that through various sort of programs of work where we look at connectivity and supply chain involvement that we can be testing out. But yeah, what comes with an advantage comes with a challenge as well. It's not all free.
And I think if I may just add one thing to that, we've talked a little bit about supply chain here. I think the other, the next frontier is how do we extend that value chain into our customers as well. So whether you're dealing with the U.S. Air Force or the RAF, or if you're a civil aircraft company, maybe working with the FAA or EASA, that those same protections, you can even look at extending those into your customer base, whether it's the DoD or the FAA, and provide those same level of access, and to really be able to enhance those communications, accelerate those communications, the collaboration that you're having, customer to OEM to supply base. So I think it really does complete the whole value chain, and it puts those protections across the entire chain.
Yeah, and Dale, if I could just come back, I mean, you've sort of answered this question, but I'm going to take one from a member of our audience, and it's one that I guess we could almost leave until as a final question, but I think we'll do it now. Given the transformation that's taken place in the last 20 years, asks Bob Ransigen, I hope I'm pronouncing your name right, where do you expect us to be 20 years from now?
Well, that's a tough question, but it's my crystal ball is I think about and I'll use a bad analogy, but where cell phones have come, first cell phones, very big, bulky, and now when you think about these smartphones, and they don't even have buttons anymore, and so I think that you're going to see a lot of transformation. Part of it is maybe in the user interface. You'll see more. I believe you're going to see much more virtual designing in context, manufacturing in context. I always think about giving the engineer the perspective of a technician and how that will change their perspective on the design. In the past, in the physical world, we used to take our engineers and we'd put them out on, we'd have them working with the shop floor and learning how their designs went. And the amount of learning that they had was amazing when they had that opportunity early in their career. And now I think, with virtual tools, you have a much better opportunity to get it right the first time. Because you're able to see that in that context. I think your interfaces are going to change. You're going to see more machine learning and advanced, the artificial intelligence piece coming in where, the system maybe is more predictive. We're doing that today. And really, then, extending that into the entire chain. And I think, we're going to see more compression of time. And we're going to see, these programs continue to go faster. I mean, we're already seeing great ambitions and actually great progress today with what the Air Force and the RAF are doing with respect to wanting all this new technology and at half the cost and in half the time. And so anyway, I think it'll allow more customization. We'll see more compression of time. We'll see more of these tasks become automated where you can apply machine learning or artificial intelligence. And so, and then one last thing that, the transformation you're seeing in manufacturing now with things like additive, being able to come in with new materials to be new methods. And with additive, you really have that entire digital thread from engineering concept all the way to finished part. That's the potential to transform, how you build parts and manufacture parts, and quite frankly, how you design the parts. And so I think we're going to see a lot of changes. It's 20 years from now, we're going to look back and go, wow, that was like the Stone Ages. So we'll see.
And Andy, you're obviously working on Project Tempest, an aircraft that's potentially going to be in service in the 2040s. How do you see this evolving over the next 20 years by the time the Tempest aircraft goes into service?
Yeah, so again, back to sort of manufacturing system and manufacturing operations, and some of the techniques that that we're working on, and we see being part of sort of the standard operations. I've touched on a few already, but and some of the activities we're involved with are actually seeing the way, not just for developing the way forward for Tempest, but we're sort of putting back into our current manufacturing processes, i.e. onto Typhoon. So things like intelligent workstations. So one particular example where we've integrated quite a number of various technologies, where it be optical projection, or whether it be smart tools, use of additive around aiding the assembly process, integrated work instructions to really reduce the amount of learning that we see. So we're bringing work back into the factory, or putting new labour onto the work. You know, normally we'd account for a level of learning, and using some intelligent workstations that are pretty agnostic to the surroundings, but very specific to the operator around the level of work instructions that are needed. We've seen the benefits already in our Typhoon project. So taking those to a further stage are quite a major advantage to us. The logistics side of it, you know, the intelligent intralogistics storage around the visible stock levels and task scheduling all comes into our control processes, and linked with that around the autonomous and automated movements of parts through the factory, which is called off by the workstation that says this is when I need the parts. So we start to integrate a lot of these things together, and the accurate position of tools and components, so we know we can optimize the workflow throughout the factory. So there's lots of initiatives around sort of connected digital factory that the trick is with us how you integrate them, but more importantly, can we actually get some benefit now, rather than, you know, this is what it's going to be, you know, hopefully in 5, 10, 15 years time. So there's certainly a lot going in that area.
Paul, can you say how this will change things at Boeing over the next 15 to 20 years?
Yeah, I do see timelines being compressed. What I envision is more of the analysis will be integrated more real time. So designers will get to see the impact of their design downstream. We'll be able to leverage more IR, VRs, you know, IA as we go forward, and we'll be able to see the impacts as we go down to the factory floor or down to the maintainer by the actions that they're taking today. So I think we'll be able to see a lot clearer as to what we're doing in the design as an impact downstream, as we can model then both the factory floor, we can model support and maintenance, and we can see not only does it impact, but what is that cost that's going to flow into the production line as well, into the support systems. I see a more collaborative environment with the supply chain, where they are, you know, as designs are being fabricated or are being pulled together, that they are able to comment on the producibility, and that they're able to take that straight out of our models and put it onto their machines without having to code the NC machines, and being more seamless in that. I think that's near term, but I just see, and I want the analysis to be much more integrated with the design, so that we can see how we are closing in on the total vehicle going forward.
Okay, I'm going to take some questions. Sorry, Andy, please come in.
Yeah, just to add to that, and certainly the opportunity that we've got at the moment on laying out the factory of the future, and having the sort of test bed and the sandpit to be able to demonstrate some of those. Already it looks very different. And there's a journey for our organisation, our operational team to go on, and particularly that's why we put some of the technologies we're working on back into our current projects to say, look, we've been building Typhoon aircraft for 20 years using the standard methods. Some of these methods that will be used in the future have an opportunity now. So the cultural barrier of introducing these is being overcome as we speak. But the factory, does look very different. Certainly from an assembly point of view, where we start to bring in intelligent automation and robotics compared to the traditional high-value, non-recurring tooling and fixturing that we've used in the past over many years of aircraft manufacture.
Thank you.
Yeah, and if I may actually just add one more thing as well, I think something that Paul said really triggered me. That one of the things I think we're also going to be able to see is the engineering workforce tends to be pretty specialized at a lot of our companies right now. And you have people that are, designers, you have different analysts for different systems. And I think that the tools now, as they become more and more integrated, it's actually going to make it much easier for people to not be so specialized. And you'll see people that are actually, they're much more involved in a bigger piece of the design, and even as that extends into the manufacturing process. And so it really does have the potential to change how people work and maybe at some level to actually make the job a little bit more fulfilling and enriching for some of them. So maybe for a lot of them. So I think it is going to change how people work, just because you have the tools. They're so much easier to use and so much more integrated.
Okay, I'm going to try and get through as many questions from the audience as possible, because that's to say we are live and we're getting lots of questions coming in, which is great. I've got one here specifically for Paul, and it's from Martha Neubauer. Paul, can you speak to how digitalization helped integration between product and production development? Did MBSE help achieve production benefits like full-scale determinate assembly? Now, you might need to just decode that one a little bit for those of us who are not experts in this subject before answering.
Well, I think determinate assembly means just how parts are going to fit together.
Okay.
So model-based design and how that influenced the build. Obviously, with model-based design, you can then achieve model-based instructions on how to build and assemble the aircraft. With model-based design, it also enables a much more simple build. Sort of what Andy was saying earlier about some of the factory of the future, but it's much more simpler build. You know with exacting tolerances how all the parts are going to fit together, and with your collaboration with your supply chain, if they manufacture the parts to those specifications and they don't try to use some of the inherent cheaters that they've done in the past, so that they know they're compliant, but don't oversize some of the holes, don't leave added material that might need to be trimmed, just make the part as drawn or as modeled. Then things come together much more easier. It allows you, with that confidence in the supply chain, and by seeing how everything comes together, you can have a shimless design so that parts do come together easier, quicker, faster. And it allows you to have self-locating parts. So talk about monolithic tooling, that's a thing of the past. I just need stands to be able to hold the parts as they're going together. And as they go together, they're going to become more and more in tolerance to the final product. So it's a different, it's a little bit different mindset. You got to trust the tools. You got to trust the analysis that, hey, the tolerance stack ups, and do your dimensional analysis. And you have to trust the approach. And we saw tremendous benefits on T7. I mean, we were able to splice the fuselage together in under 30 minutes, which is like for us a 95% reduction in time. but it was all about knowing that we had the tolerances, and we knew that the pieces were going to go together, just as it was shown in digitally.
That's fascinating. We talked earlier about the 36 months that it took you to take the T-78 from concept to first flight. I mean, Dale, maybe I can ask you, just, I mean, give us some examples in terms of, I don't know, percentages or whatever, what the potential of this is. What are we talking about by using this technology as opposed to not using it? Are you doing things 10% faster, twice as fast? Just give us some thoughts there.
Yeah, I think there's probably not, a single hard and fast answer. I guess, I think when I look at, in total, maybe you save 20 to 30% of the total development time of your program. Even, whatever the numbers, 30, 40, 50%. We're seeing, we do see a lot of customers, I think, that consistently, when they look at the totality of their program, and maybe they're not fully digitized everywhere, but they're seeing 20, 25, 30% improvement in their cycle times. So start from the time they start to the time they finish, they've reduced that 30%. That's real money. I mean, you have big teams, and that's real money. When Paul talks about, the reduction in the assembly hours and what Andy's talking about, I mean, that's like a lot of money. But the beauty of it is there's organic learning that's going on at the same time. And so you save 20% the first time, you save 20% the next time, you save 20% again. After time, that really starts to add up, and you cut your programs in half. And that's the beauty of the digital processes now, that, when you start taking these model-based approaches, that you're able to, you have more traceability of your decisions. You're able to, take greater advantage of reusing that knowledge. And because you have this really good understanding, you're able, learning from how it actually worked when you built it, you're able to take that learning and apply it to the next time. And so it really does make a big deal. And I mean, I'll echo one of the things that, Paul was saying about you're not trimming, the manufacturing team would add extra material so that they could trim it to fit on installation. And, kind of the first time I went down this path with the program, the guys left 1/4 of an inch on every part because they didn't trust all of this digital piece, and they were going to trim it all to fit. And they pretty consistently cut 1/4 of an inch off of everything. And, so so if nothing else, it validated the models. But it is, I do think that when you start looking at the whole process from model-based systems engineering, your requirements, you flow that into your design, your analysis, your manufacturing, you're able to have all of the tools working together, and you're able to learn over and over again, and you accelerate that learning and you accelerate your programs. It's pretty amazing what you can do in 2 or 3 programs.
Andy, would you care to say, put a figure on it? What?
Yeah, it's a difficult one. Well, it's a great question. It's always a difficult one to put an exact figure on it. I mean, we've like I said in introduction, we've from a next generation aircraft point of view, we've got some quite significant targets and challenges that we put in there around significantly reducing the lead time of getting the product to market, whatever that product is, whether it's a detailed part, the assembly process, but all that contributes to getting the time of a concept of an aircraft through to it going into production. So we've seen examples where we've taken significant lead time out of the manufacturer detailed parts through sort of the digital processes, including additive manufacture, and avoiding the need for large cost forgings, for example. Through to the example that Paul was talking about, really, that says the real cost around the assembly side is the strip and deburr and the pilot holes and opening them up, and by using the accurate robotics and the sort of digital technologies at the moment, we can take significant cost and time out, and some of it varies. the figures that Dale mentioned, around 20%, it varies. I think our aim is to halve the time it takes to get our products to market and actually halve the cost to do that. Now, some cases we can see dramatic months down to days around design and engineering processes. But at the moment, we're doing that check that says conventionally, how do we build a Typhoon aircraft, for example, and what advantages, and we're capturing that as we go through the Factory of the Future type activity. But we are seeing some significant advantages as based on this, and it's measured in our case around the cost, the lead time, and the quality of the products as well, in terms of any rework or inspection that needs to be done. So there's the whole series of cost drivers that we look at that give us the advantage that says this is why we're doing it. It's not just a good thing to do using sort of data science and digital technologies, but there's a real reason behind it, and the majority of it is actually taking the non-value added activity out of the process.
Yeah, I mean, this kind of brings me on to my next question, and the aerospace industry is going through its biggest crisis probably ever, certainly on the commercial side, perhaps less so on the defense side, but we've yet to see how it's going to impact the defense sector. Does the current situation make it easier for people such as yourselves to convince your bosses to invest in this sort of technology as we emerge from the COVID crisis? Can you make that case more easily now? It's obviously going to be, investment funds are going to be tighter in pretty much every company in the world, but at the same time, can you make that case for the saving as we go into kind of leaner times coming out of COVID? I don't know if you want to come in on that one.
I'll start. So I think it is challenging because gone are the days where there's lots of discretionary funding available to do R&D research work that says, well, this is the art of the possible. I mean, you think of the business cases that need to be put together. The return on investment is quite critical right at the start, and sometimes you're just not so sure. Your gut feel might be it is the right thing to do, and really you've got to go with the trust of some of the technologies that says these methods will provide a benefit. Now, from a financial point of view, business cases that are signed off want to see, well, if I invest this, will I get that return? And it is difficult. So it's not. I'm not saying it's any easier. But we know we've got to break the paradigm and shift the paradigm, because we may have within our manufacturing facilities pretty world-class capabilities around F-35 aft fuselage manufacture, for example, and our Typhoon assembly process in the 90s was probably best in class, but not good enough. We know we need to change. So we've got to have some level of investment into changing what we do, but also we've got to demonstrate the benefits, not just do research work in research centres or in some of our test areas. We've got to realise the benefit to say this is exactly the cost and lead time and quality improvements that we see. Not that we think it might be okay. So it's not any easier.
Paul or Dale, would you like to come in on that? How do you make the case for this sort of investment in technology in such straitened times?
Well, I think a couple thoughts there. One is we've had some demonstrated success, and if we want to continue that journey, we have to show what those projects are and their applicability to the product itself, not just R&D for R&D's sake. I think we have to be more deliberate in pointing toward what we're trying to do to affect the product in the future. I also think we've shown with this new environment that we can have some workforce flexibility, that we all don't have to be in the same room to be able to collaborate and design. So it allows us to have some balance and some flexibility on where we can design from, because we can all collaborate in a digital environment. So I think that is really played out a little bit more during this year than it has before, and has really opened people's eyes that, yes, I can, design from anywhere. I can have folks across different time zones working together in the same single source of data. And that way I can have some balance and some flexibility in the workforce that I'm maintaining.
Yeah, I think I'll both Andy and Paul, great comments there. I especially like that last comment. 2-3 years ago, as an engineering leader, we were struggling with how do we let people work remotely, because we had and maybe at some extent we were managing by activity. We were looking around and seeing if people were there, but I think that it was forced upon us, and it was amazing that the companies that had the digital tools in place, they were able to really see very little impact on productivity. I will comment that even in 2008, 2009, when we had that that financial crisis, which hit the commercial side pretty badly, also hit the defense side pretty badly. That companies did continue and invest in digital transformation in some of their digital journeys. I can from my personal experience, we continued to invest in it, and but we had to, as Andy said, we had to really justify it. What's the benefit? Why are we doing it? And because I think our companies all recognized that at some point in time we were going to come out of it, and we needed to be ready to come out of it to be a leaner, meaner organization. Maybe the unfortunate thing is that our bosses all remembered, the commitments we set of how much time and money we could save, because in the next program we had to live up to those commitments. But the tools were in place to support that. And so I think just on a maybe slightly different thought, that as you go forward and you're looking around at your workforce, and you're looking around at the tools that you're bringing in and the collaborative tools. One of the challenges some of these companies are facing as they start these new programs is just hiring enough technicians and engineers. And it's not about cutting people in many cases. In most cases, I've got to go out and hire 1,000 engineers or 1,000 technicians to go execute this program. And I'm also going to have some workforce attrition because people are going to retire, people are going to leave. So I got to go out and hire 1,500 people, pick a number. Well, I might be lucky to hire 500. And so I've got to figure out how to close the gap. And in my experience, closing the gap sometimes is being done through these digital tools, that you're being able to have that workforce flexibility. You're being able to have more productivity, be more collaborative. And so really, it really can help address a lot of those areas in terms of being able to get staffed properly and then be able to execute your program on time and on budget.
Excellent. And that brings me on to the next question, which I'm going to take from a member of the audience, Ha Fung Lee. I hope I've pronounced that right. What kinds of skills from the current and future workforce do you think would be needed or will be needed for the future of digital engineering? Are there new skills that need to come in? Is it possible to retrain existing workers? Talk a bit about what it means in terms of upskilling your workforce.
Okay, I'll start with that if that's okay. Yeah, I've no doubt that we're walking into not only a factory of the future type environment, but also the engineer of the future. We think about our traditional apprentice schemes, range again within operations area of machining, fabrication, welding, pipe bending, all those traditional manufacturing methods. Some of them will be the thing of the past. So we're moving now into a more digital type engineer, one that's more familiar with designing, programming, 3D printing machines, for example. So that brings a whole challenge certainly within our industry of professional staff, shop floor staff responsibilities, the use of more automation type engineers, and we've got a blend within working in our factory of the future, which is a combination of apprentices, graduates, early careers, and colleagues with 20, 30, 40 years experience, and it's a fantastic blend. And you know, we get the challenge from our early careers that says, you know, why have we got all this paper around? Why have we not got an app? Why are we you know, not doing it this way? I don't understand. And it's a great challenge. And the example I gave before of putting some of our newer technologies back into our current production line is really to test them out. And I'll just repeat the example of one of our operators who'd been building a certain part of Typhoon Echo for 20 years. We gave him some new technology. It was optical projection, it was smart tools, the work instructions provided to him digitally, and probably first expected the response of, well, I don't really need that because I've got my little book that explains how to do the job. I've done this job 20 years, I can do it with my eyes shut, I don't really need any of that, and what's it going to do for me anyway? But we purposely gave it to him and he embraced it and said it's made his job easier. So that's a great example of a blend, but also equally the challenge of what benefits are going to give us. Is it going to reduce the amounts of operators that we might need, for example? And it's all about taking the non-value added activities out. So that's what we see, and we are now starting to work very closely with the trade unions, for example, of what the roles are in the future, and they will change shape. There's no doubt about it.
Okay. Would anyone else like to come in on that one?
I think Andy had a great answer. The only thing I would add to that is with the automation and more compressing of design and analysis, I think we're going to see folks rising up to be more system level thinkers, more what I would term athletes that are capable of doing more than one particular job. And so they'll have an understanding of the system. And so that will be able to help inform them and help us get a better product in the end, because they won't be stuck doing some minutia type of work that they're just grinding through every day. That will be left toward the tools and some of the automation, some of the machine learning and things like that, and then they'll be brought up to a higher level and have a better understanding of the complete picture.
I would just add to that. I think that was a great example, great characterization of, I think, where the workforce is going. I mean, the skill sets are definitely changing. You're seeing, you're seeing more electrical systems, you're seeing more software, and there are skill sets that are needed. But I do think we're going to see more people that become much better understanding of the big process, big picture. And that's going to be important, because as you start to have more of this automation, more of this reliance, you have to still be on the digital solutions. You still have to be grounded in the physical world as well. And so there is always going to be some validation, verification back to that. But people have to, if they understand the system, they understand the manufacturing process, they're going to be able to sense that, yeah, that's I'm getting the answer that I expected to have, and they'll have trust in it. I think it goes back to a comment Paul made earlier about they got to trust the digital solution that's there, and you have to have a basis for that trust. And you go through that learning, much as what Andy's talking about. So it's and quite frankly, I mean, I think we're finding that people are much more adaptable with these digital tools today than they used to be. Certainly, the engineers and technicians that enter the workforce over the next 20 years, they've grown up on iPads, and they are used to just doing it. And there's maybe even some level, there's a little bit of a more natural trust, because they've been around it their entire life. And so it is, I think, there's the skill sets differing. People will adjust and adapt.
I've got a great question here from João Villarino. Again, hope I'm pronouncing your name correctly. and it's to do with, I'm going to paraphrase, but it's to do with EASA and FAA and how they regard digital engineering and in terms of certification. Are these entities, he asks, ready to certify and approve P21 DOAs that will accomplish tasks with the support of digital and virtual tools? And he feels that these entities are quite conservative on accepting change and are only now starting to move towards paperless processes. Don't want to get you into trouble with the ASA or the FAA, but does anyone have a view on that?
Yeah, I can start off on this one. I've worked with certainly with the FAA and the ASA quite a bit in my past lives, but I talked to some of our customers that are trying to go down an approach of more digital certification, and honestly, the certification authorities, they're not necessarily there yet. They're still heavily document centric. But I think as they get exposed to the tools, the value for them, if you're the, and we'll just say the FAA, if you're the FAA, the value for you is that when you go and you audit a process, which is a lot of the certification involves the ability to trace from those requirements into your design, into how you verified and showed compliance to the rules. It's a kind of a traditional systems engineering process. As you go to those model-based systems engineering processes, and you actually have that digital thread, and they can start auditing it, they're actually going to go back and go, look, this is actually easier for us. And so, you've got to show them, you've got to demonstrate it to them that you have the traceability that you're saying that you have. But once you do that, I think that they'll accept it. And and I think that's the piece. I mean, 15, 20 years ago when I was participating in a software audit, and the guy goes, okay, show me how you showed compliance to this requirement. I mean, people were like scurrying for file cabinets, for data on shared drives, and there was like no one place, and it took literally like a day or two to pull all the information together. As opposed to today, you push the button and you can see the entire life cycle of that requirement and all of the associated analysis and designs with it. So I think they'll get there, but you have to have an internal process that builds on the successful PLM tools that give you that thread and that connectivity, and then you have to work through it with the FAA.
And your poll, are the certification authorities, the regulatory authorities, have they caught up with you?
I would, I just generally kind of echo Dale's comments. I think we have to demonstrate that. I think this is new from a verification certification area, demonstrating that the models, the simulation, the digital thread, how the models are validated to give them confidence that we don't have to go test or fly every point, that we can focus more on where the uncertainties, where the modeling and simulation say there's uncertainties, and focus there. I think digital engineering provides you a great opportunity as to define your instrumentation locations, your tolerances, and so that when you do the test phase, that you are more efficient. There's an element that provides that test efficiency, as well as then how do I use the models to then complement or help supplement some of the test and certification traditional artifacts. So there's opportunity there. So I look forward for that to continue to progress as we go in the future.
And Andy, from BA's point of view?
Yeah, and for me, probably a couple of angles to that. One is where we can build on the experience that's been gained over a number of years, really, of introducing new things like go back a number of years on composites, go back superplastic foam and diffusion bonding. So we've introduced new things into our design and operational areas over a number of years, and this is probably nothing different. It's just that we get a bit spooked by it. Well, it's digital and it's you can't really grab hold of it and see it. So a couple of things for us is taking the certification authorities or the type accepting authorities on the journey with us, and they're very much part of what we do. So they see the themes, they see the activities we're involved with. We've got product test and validation as a key theme in our technologies areas, and also we look to aim to reduce and shrink this qualification pyramid. So yeah, we can use some of the digital twin methods to overcome some of the inspections that we might have to do in the future, so we can build in simulate defects and inspect them in the process rather than afterwards. So yeah, bringing them on the journey from a type acceptance point of view is important. Looking to see how we can certify and qualify some of the processes as we go on there, and building on the experience that we've had introducing new methods and technologies in the past has helped, always helping.
Great, okay. Well, we're just about at the end of our time today. I'm just going to try and squeeze in one last question from the audience. So if you can just try and answer this as quickly as possible, but it's from Andrew Chaplin. And we talked about supply chain earlier, but he's asking, how does the digital revolution affect how you work with supply chain companies? And if build to print works first time, or if all this is so successful, how does it affect, how does it influence the roles of tier 1, 2, and 3? How does this affect your relationship with the supply chain, perhaps particularly at the smaller end of the supply chain? Maybe Paul and Andy, would you like to come in with that very quickly?
I would just say it allows much more faster collaboration, faster teaming. We're not waiting a lot for transactional relationships. We are pushing things back and forth, and it's just more collaborative in my mind.
Yeah.
And Andy, do you sometimes have to take the smaller companies on that journey with you?
Yeah, and a key thing, we talk about a high percentage of our operations is in our supply chain, and we can think about, well, big organisation, BAE Systems, have got the wherewithal maybe to look at some of these technologies and expect the supply chain to do the same. So part of our Factory of the Future activities probably got 50 plus maybe partners involved, ranging from SMEs, supply chain, academia, research centres, large primes, and being on the journey and being involved, and then the collaborative programmes that we've got. A lot of UK initiatives are very much around organisations like ourselves setting the challenge, and suppliers, so NATEP, DTEP, technology exploitation programmes, give the opportunity for supply chain to really start to understand the challenge and get ready for it. But it's incumbent on us, our organisations, to take the supply chain with us on the journey. We can't expect, it's all going to happen in the background of small SMEs that have been in place for many years, using traditional methods of subtractive manufacture, for example.
And Dale, very, very quickly, is this something that the Siemens products and others, is this something that small companies, small SMEs can embrace in the same way as Boeing and BAE Systems can?
Yeah, no, absolutely. I mean, I think that a lot of the design tools, as we look at the accelerator portfolio, it really does scale to a company of any size. And so the benefit of that is to be able to provide this access to the same tools that larger companies are using, and so that they are part of that collaboration process. And so they get the same benefits, they from their time savings, from their cycle times, but they also get the benefits of being able to collaborate more effectively with their primes. And when they can do that, they're more efficient and they can win more business. So it definitely does. Companies of all sizes are benefiting from digital transformation. It's not just the big companies and like the DoDs and MODs. So
yeah, an opportunity for everyone. That's a great note on which to finish. Thank you so much for your time. We could have talked about so much more, but time's got the better of us. I'd like to thank all our panelists for giving so generously of their time and their expertise today, and especially to Siemens for their support. And thank you all for joining us today. Thanks for your questions. Apologies that we couldn't get round to more than a few of them. There were some great questions in there. A download of this webinar will be available shortly on FlightGlobal.com, and there will also be a report running on there in due course as well. Now, you can join us again on the 15th of October when we'll be covering a very different topic, network planning in North America, and the challenges facing airlines and airports as they begin to rebuild route strategies after the biggest downturn in traffic there has ever been. So thanks once again for joining us. Stay safe and see you soon.